Windy day today. They say gusts up to 80 miles an hour and surfs up to 12 feet. In the middle of January. All right, well, you do have a homework assignment due today, so any questions about it?
Yeah.
We do. Okay, 12.5.
No, 3.5.
Oh, 3.
35. It's prove the max number of leaves equals.
Oh, 35.
I got the base case, n equals 1.
Oh, that's this. Hold on.
But
Okay, so the problem is to prove 12.35a. The maximum number of leaves in a tree with height n is 2 to the n minus 1 for n greater than 0. And you got the base case, so the base case is what? N equals 1.
because it's not equal to
Right. Okay.
class.
Yeah, starting out the same as we did in class.
Put let DLR be a height n plus 1 tree with max number of leaves, but I couldn't say you must prove pound DLR. Because
Yes.
that would be all of the.
Right. Well, yeah, so you don't use the pound notation, but just do, I don't know, make up something. Num leaves or max num leaves. Well, just say max num leaves. I mean, or write it out. Is it the question just how to write it out or what symbol or? Well, I mean, it's the same idea of 12.35a, and we're doing the induction case, right?
Correct.
Well, I mean, you set this up the same way. What you do is you know, the tree looks like this. You know, where this is L and this is R and this is a tree of height. This is a tree of height n plus 1. So here this is height n plus 1 from here to here. All right, and then from here to here is height n.
Well, I mean, if we're gonna do it like this, I think I understand it. I didn't know if we had to do it like formally, because for the other one it was easy to do it formally because you could just do the notation pound DLR.
Right.
It would make sense, but in this case,
Is it kind of informal?
Well, it's kind of informal. Yeah. There's not a I see what you're saying. In other words,
I pretty much just wrote a paragraph explaining it.
yeah. Well, I mean,
because you can't use 1231 because it might include more nodes or leaves. And
the thing of it is that we don't. I see what the problem is. The problem is in the previous one we had 12.31, which is the definition of number of nodes, but here we don't. Here the definition of leaf isn't an equation.
yeah.
You see what I'm saying? I mean, I see that's what the problem. That's where you're stuck.
Correct.
Yeah.
So we can just write it out.
So you can just write it out, but there's still a little bit of math involved because tell me,
Yes.
there is still a little math involved. So you can have a little formal math step thing because in order for the tree of height n plus 1 to have the maximum number of leaves,
Needs to have the maximum.
then L must have the what? Maximum number of leaves, and R must have the maximum number of leaves.
The leaves in L plus the leaves in I must equal the leaves in DL.
Yes.
Propagated trees.
Yeah. So if this is D, yeah. That's the D, and here's the L, and here's the R. So, and you can argue. I mean, that's you have to make that observation. Yeah, that's how you make that observation. That the maximum number of leaves in a height n plus 1 tree, in order for the height n plus 1 tree to have the maximum number of leaves, then L from here to here, then the left subtree is a tree of height n, and it must have the maximum number of leaves, and R, also of height n, also must have the maximum number of leaves. So therefore, the maximum number of leaves in this is maximum number of leaves in this plus the maximum number of leaves in this. And then if you calculate that out, you'll get the induction case. I mean, you know, because the inductive hypothesis, you know what this is by the inductive hypothesis, you know what this is by the inductive hypothesis, then you prove this one.
That's what the proof is.
Yeah. But it is true. You have to write it. There's no there's no equivalent to 12.31 that we can plug in.
Well, I mean, unless you,
But I think you should draw this in your proof.
Yeah.
Yeah, I know. Some people, some people will rebel against having to write down too much. Anyway,
How
yeah.
about the induction case for 1235B?
What was 1235B?
Prove max internal nodes equals.
Oh, well, what do you think? Yeah. So if we were doing 1235B and we were having to argue for the maximum number of internal nodes, well, can you tell me with this exact same picture, can you tell me what the argument is for the maximum number of internal nodes?
Well, if L has to
Have maximum number of,
internal nodes.
and R has to have the, and,
And the total is 1.
but this is also an internal node,
That's
so
one.
it's
One
1 plus. Yeah. So there's a 1 plus in that one that wasn't in the one before.
Great question.
Another question?
Yeah, regarding induction in general.
Okay, induction in general, yeah.
Well, the problem I went off was 12.5.
12.5.
It says prove that, whatever it is,
The sum over I, range
all
0
that
less than or equal to I less than n,
Full-
body R to the I
Yeah.
equals R to the n minus
and
1.
then for R is a real number, R is not equal to
One.
1. And do I need to re-quote that every single time, like for the
No,
induction case?
no.
So like, for example, when this is for n greater than or equals 0, you don't need to re-quote that?
No,
Like, okay.
yeah. You don't need to requote
so in the-
all of that
So the
verbiage,
induction case was like prove
Prove
sum over I equals,
equals,
etc.
et cetera,
Assuming-
assuming sum over I without, Yeah, no, you don't need to quote all of those provisos. Now, by the way, do you see the proviso why R has to not be equal to 1?
Yeah.
Because if it were, what would happen?
One that doesn't work.
Well, because you'd be doing what? You'd be dividing by 0.
Sure.
And by the way, how do you know what the base case is? Because they don't have,
This is n is a natural number.
it says natural numbers, and you know that for the base case for natural numbers,
0.
0 is right. Because we know what natural number means, right? All right, these are good questions. Is that it on the questions? Man, you guys actually are asking questions and handing in homework and not waiting until 5 o'clock in the afternoon. I'm impressed. Okay. Let's move on then. So the video was good. You were able to, those of
Yeah.
you who have to rely on that. All right. Now, last time we talked about formal specifications. And the numero uno question that I will ask now, that we learned last time, is what is the shape of a formal specification?
The bracket thingy.
Bracket.
Yes, it's a Hoare triple that starts with, yeah,
bracket,
it's bracket,
You
Q, bracket, and then it's X, gets, question mark, and then it's bracket. I forget what we used.
What was so tricky about that? You talked about it for like,
I know, and the reason, I know. So here, let's see if you got it right. Yes,
Yeah.
that's the shape of a, yeah.
you kept talking about that.
I know, because, because I gave a prediction. I gave a prediction that,
I think your prediction's wrong.
well, maybe you prove me wrong. I hope you prove me wrong. That's why I emphasize it's based on, based on past experience. Now,
We're all gonna fill something in for question.
no, I mean, what you'll do is, here's what you'll do. People will do this. They'll do for all X, blah, blah. They'll just start off like this. They won't do this. I mean, they'll.
What if we write told you so into it?
Yeah. All right. Now, here's the thing. To write a formal, one of the things that we want to be able to do is when someone, like suppose you go to work and your boss tells you to write a program, and he says the program should do this and this and this. He tells you that in English, right? Or maybe in your mind you want to write a program and you think in your mind, okay, I want it to do this and this and this, and you think about it in English. The next skill that we need to learn is how to convert from English to formal methods, okay? So now, in order to write down a specification, tell me, this precondition Q, what is this Q? What's the shape of this Q? It is a Boolean. It's a Boolean expression. What's an expression?
Oh,
A
no.
constant or variable.
Constant or variable. If E is an expression, parentheses is an expression, etc., etc. Okay?
Exactly.
All right. So that's what this Q is, right? It's a Boolean expression. All right? And this R is also a Boolean expression. The postcondition is also a Boolean expression. Okay? So we need to review now, and your homework assignment for next time is a bunch of exercises on how to translate from English to formal methods so that we can start, so that we know how to write, convert from English to writing this. Okay, so we're going to start with some easy ones, and I think you've seen some of these before. So let's do English to math. And this is for exercise 10.1. All right. So now, how would we say here? So I'm going to write English. You tell me. We'll go around the room. I'll write in English. You tell me how to write this formally. X is positive. So Ben, X is positive. How would you write that mathematically?
X is greater than 0.
Yes, X is greater than 0. Okay, so Kyle, X is negative.
X is less than 0.
Yes. X is less than 0. How about, Alex, how about X is non-negative? X is non-negative. What would that be? There's actually two ways to do it. Yeah. So, well, let's do it another way first. If you say non-negative, how do you write non? Yeah, not. And then this is negative, right? So you could say not X is less than 0. But what you said is also correct. Another way to write it is?
X is greater than equal.
Yeah. X is greater than or equal to 0, right?
Greater than negative 1.
Hmm?
Greater than negative 1.
Oh, that's another way. Or X is greater than negative 1. Yeah, that's kind of an unusual way to write it.
Well, okay, never mind.
But you
If you
could.
get negative decimals, it can be.
Well, I mean,
That would just be this.
well, yeah, anyway. Okay, now here's another, okay, Josh, you got this one. How about this? X is an element of B, so B is an array, subscriptive variable, 0, n minus 1.
How's that English?
That's not English at all.
All right, let me say it. Okay. X is in B. X is in B. 0, n minus 1. Okay, so there's.
Oh, just write down what you just erased.
Yeah. Okay. Well, but how about? Okay, so you could say X is an element of B. 0, n minus 1. But what's even a more detailed way to say that? Actually, I wanted to start with this.
For all, no, there exists.
Which is it? For all or there exists?
There exists.
Okay, so there exists an I. No, wait. Did you say X? Did you want to say X?
Yeah, I can say X. That's fine.
Oh, I don't know if you can say X or not.
Oh,
No, I don't think you
No,
can.
you can't.
Because this X is
well,
free.
Unless I rename
No, yeah, you're good at renaming.
Oh, God.
That's a different X. Yeah, you would want to have 2 different X's in the, yeah. We've had this discussion before.
Oh, let's not be that.
Okay, so there exists an I, range what?
True, I guess.
No.
Oh.
Ooh, hold on. Range what?
Well, that you didn't write the range. So.
Oh, sorry, you're right, I didn't write the range.
Keep up.
Yeah, sorry.
All right.
Sorry.
This is an element of.
Okay, so there exists an I, range what? Shh. I didn't think your name was
0.
Josh.
Apparently it is. 0
0?
is less than or equal to n minus 1.
No.
Isn't it eyes?
Hold on, okay, man. We got so many people named Josh in this room. Gosh. I,
God, I'm rusty.
you are,
Less
yeah.
than or equal to n minus 1.
Less than or equal to n minus 1. Or you could say,
How do you know if it's less than?
oh, that's a good point. When you use this notation hold on. When you use this notation to denote a range in an array, it's the first one and the last one inclusive.
Oh, okay.
That always means that. So that's the convention. That's what this notation means. So we could say less than or equal to n minus 1, but it kind of better.
Less than.
The preferred way to say it is what?
Less than n.
Less than n, right?
That's not preferred. Oh, wait.
Yes, this is preferred. We even had
Body.
we even talked about this being the preferred one. Yeah, we did.
Body.
Okay, body what?
X equals I. Is that
Don't write this down. Is this correct? No, it's not. Hold on. Yeah. It's X is X has to be in there. But what is the I? Is the I the index?
I, where X is equal to it. That is right.
No.
Wait, why do you have to have
It's
it
not
up there?
X equals I.
How come you can't use X as your I?
Because this X is free and this I has to be bound.
Yeah.
This X has to be free in this expression.
Yeah.
And this I is bound to here, so you can't use this. But this is incorrect. Okay, Ashley, hold on. Okay, Ashley, why is this incorrect? Do you know what the answer is? Hold on.
I agree with Josh.
Oh.
Well, it's just saying that X is one element. Or is that a big
But this expression is incorrect. Can you tell me what the correct expression is?
I know that's incorrect, but I don't know what. Is it the X
Okay,
is the
Ben.
element of?
No.
I know.
Oh, yeah, okay, you want to go skip back?
Can I save myself?
Save yourself.
All right. X equals BI.
Yeah,
Yeah.
equals B sub I.
I would have said B dot I.
Well, no. The dot is a function.
Would've been wrong.
This is an element of an array.
It could be a function that returns the element.
The element of it. Actually, it could. Yeah. But okay. Now, does everybody get this? Does everybody understand why it's this?
Way harder than it has
X. Yeah. Okay. So this is how you would write X as an element. You'd say there exists an I 0 less than or equal to I less than n. Body X equals B sub I. Because I is the index, B sub I is the value that's stored in that index. And when you say X is in there, you're saying that X is equal to that value, not to the index. I is the index. The index is between 0 and n minus 1.
Is there a way you could write it with X equals I in the body?
No, I don't see how.
Couldn't you have in the range, instead of I, you have B of I?
Can't you not say X equals I because it's an element of B sub I?
Yes.
But no. But you see, when you say X is an element of, you are saying that X is one of these values.
Right.
You're not saying that X is an index. See this, I mean, these B's could be doubles. They could be
Are
reals.
those that, inside for the element of bit, are those the 0 dot dot n minus 1? Are those values or are those indexes?
No, the answer is these 0 dot dot n minus 1s are not values, they are indexes. They're indices.
Oh.
Look, it's like this. here. It's like this. Here,
Oh, yeah, I
if
know-
this
I know
is
how
B and this is 0, this is B sub 0 sub 1, 2, 3, 4, 5, 6. And here what we have is n equals 7, right?
Right, anyway.
And so if we're saying if this x is 13, then it's like saying 13
So when you-
13 is in here. So if 13 is in here, the I that exists is 4.
Oh, that's where I was getting mixed up, because I thought those were the.
We were saying
The
X is element of
values.
B.
No, these
Yeah,
are
how
not.
would you write B of that with, instead you write the values? Would you just write
Here, hold on. The fact that this 13 is in here, this fact is that 13 equals B sub 4.
Oh, yeah.
Are you with me on this?
I know how I read it.
That's saying x equals B sub I. 13 equals B sub 4.
All right, but
Go
what
up
is,
one line.
how would you write B and write out its values? What would be the notation to write it? Because I that's what
Oh, you mean like to write out what all the values are?
Through n minus 1 with values, and therefore.
Yeah, it's, okay, it's an ordered, all right. Well, we haven't done ordered pairs yet, but, okay, it would be like this. Suppose let's make up some values. Let's say 27, 16, 33, 19, 13, negative 6, and 42, all right? So the way you would write this is you would write B equals, and one way to do it is to use these angle brackets, and you just separate them with commas. 27, it'd be 27, comma 16, comma 33, comma 19, comma 13, comma negative 6, comma 42. It would be something like this.
Okay.
I mean, that's how you would. But when you say B sub, when you have the square brackets, that means these are the indexes,
Right,
the
right,
indices.
right. Okay. So if you want to say x is an element of the values, could you write that and then you say there exists
You mean
an
x
I
is-
type B?
Well, you wouldn't say x is an element of B if you wanted x to be an index. Is that what you, are you
Let's
wanting
say
x to be?
want X to be the value. Well, because that's what you're doing. You're saying
Yeah.
x is the value.
Yeah,
Yeah, I mean, if you did it regarding the thing with the angle bracket,
yeah.
could you say x is an element of that, and then have there exists an I type B,
No.
range true?
No, B is the array. B is all of them. B is the collection of all of them in ordered like this. That's why we use angle brackets. It's an ordered.
But B can't be a
Yeah,
type.
but you can have x as an element of B.
Well, I mean, if you, you can't. It's a legitimate expression to say x is an element of B, and but hold on. Yeah, and yeah, hold on. It's legitimate to say this if you want to like omit this specification
Yeah.
to say how many they are and how they're indexed,
But can you then say?
and then you can say.
you say there exists an I type B, range true.
Hold on. If you say x is an element of this and you write it like this, 27, 16, blah, 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 then the problem with writing it this way is that you haven't specified what the n is and what these indexes are. So it's then, so this is not as good a way to write it as this way.
Can you say there exists an I type B, range true for which x equals
No. If you say I type B, I is an integer. I mean, B is not a type. B is an array.
Right.
An X to value.
B is a collection of values.
Got it.
Well, I'm glad we're going through this. This is good. Does everybody understand? Does everybody understand how? This is kind of like you have to keep the types in mind, right? B is the collection of things. I is an integer, which is an index. And here, look. I mean, I is normally a natural number. You normally don't start your arrays with negatives, But the values themselves could be integers. They could be negative, or they could be reals. This could be 5.5.
Could be unreals.
Whatever. Okay. All right. Now let's do another one. How about? I think you've seen this one before. How about who is next? Actually, Ben, you're next because we already asked Ashley. Okay, so how about you say x is even? But we've seen this before, right?
Oh dear, I'd have to go back and look.
Oh, come on, let's think about it and figure it out.
Or
Now, what does it mean for x to be even? We've done this about
set over I.
3 or 4 times.
Did you set over I?
Set? No, not set. It wouldn't be. It would not be set.
Okay,
My name, Ben.
then it's
What has to be true? Why is here? And let me ask you this: Why is 12 even? Because why? Because
divisible by 2.
yeah, but I'm using multiplication. Do you remember we used multiplication for this?
Okay.
Why is 12 even?
K times 2 equals it.
Yeah, because what exists? Why is 12 even?
There exists
Because what number exists? Now, for this particular example, why is 12 even? Because what number exists? What integer exists?
2 or 6.
6, because 6 exists.
Okay. So there exists
Okay, so there exists.
I.
Okay, there exists an I,
Range true, right?
range true, right?
Where I equals no. K equals I times 2.
What's k? We're saying x is even. not k.
X equals 2I.
Yes. Okay, so that's how you say. Okay, so now is it ringing a bell now?
That'll cover every value.
Yeah, yeah. Okay, x is, you already know what I'm going to ask, right? You already know. X is odd, so what is it? Yeah, but we normally use plus, right? We prefer multiplication and addition instead of subtraction. Okay, so x equals 2 times I plus 1, right? Alex, how about x divides y? Another way to say that is, you remember how we said that? X divides y, like this. But how do you do it using quantification? Exists I. Range true. Yeah, now what equals what times what? Now, x divides y. Now, remember, x divides y. What's an example of x divides y? An example would be, does 5 divides 30, right? Okay. Hold on. Okay. So what equals what times what here?
Y equals 5.
X, well, yeah, but not for this one now. For this. So what goes here? What? Y? Yes. X times I. Yeah? Are we good? X is a power of 2.
Is that for me?
Yeah.
Oh, all right.
X is a power of 2.
There exists an I. Range. I don't know. True, possibly.
Yeah.
Not good.
So in order for X to be a power of 2, give me some examples of what values, 2, 4, 8, 16.
X is a power of 2.
So one possibility is like 16, right, for X.
To the power of I equals X.
Yeah. Good. Okay? So those are just some little warm-up exercises to see how you to do this translation
How does
thing.
this relate to formal specification?
Well, the way this relates to formal is this is the kind of thing that you're going to have to translate when you do the Q's and the R's in a formal specification. So your assignment for Monday is just to do these translations from English into formal methods, and then the one after that we'll finally start doing some actual specifications. All right. Okay, now. So, and now I'm glad we did this. I was going to do something like this right now, but since we've already did it, you brought up a good question. We'll leave it at that. So yeah, you're my plant.
You said that last time, too, multiple times.
Okay, so now let's actually do some examples of specifications. All right, and in all of these, what we're going to do is we're going to suppose that x and y are integer variables, okay? So I don't want to have to write that down each time, so we'll just write it once. All right, so here is your first problem. Now see if you can do this. Specify, now I'm going to give you a phrase in English and then you have to write down the specification. Specify, set x to y's value. Set x to y's value. We'll start real trivial and simple. Set x to y's value. Now I want to see, write something, try to do this on a little piece of scratch paper or whatever. Now, do you remember what a specification is? A specification is not, a specification is, what's the specification? Says, well, I know, but in English, what is it? It says,
What?
it says what, not how. What you just said was how. So let me see your specification.
I haven't started it yet. Well, okay.
Oh, good. At least you wrote down the first character right.
There's an, there's an x, now it's y.
No, what are you gonna, what's the shape of it? What's the very first thing you write down?
Bucket.
Did you do that?
Yep.
Yeah. Easiest.
Yeah. Okay, now, do we have any preconditions? I mean, in order to set x to y's value, is there anything, you know?
Both have to be the same type.
Int x.
Yeah, and we will already
Yeah, the
suppose,
seven.
we will already suppose that they are like this. So we don't have to say they're the same.
So no. Nothing.
There's really no, nothing special, so you say true.
Oh,
Nice. It's a Boolean expression.
Because that is a Boolean expression,
Okay.
okay?
And you have true again.
And then you just say x.
No.
Well, x gets
And it says set x to y's
X
value.
gets question.
So x,
We always write x gets question mark, right?
well, not necessarily x, it could be something else depending on how we say it up here, whatever.
Variable can change, but
Yeah.
it's always the question mark.
And
Is
it's
it so
true.
true again?
What happened to y?
Nothing happened to y.
What is the meaning? Tell me the interpretation of the tell me the interpretation of Q, S, R. What is the meaning?
Q is true.
If Q is true, you execute X, it does what? It terminates, and R is guaranteed to be true.
S is guaranteed.
So is it?
So what goes here? The guarantee.
Y?
That's the guarantee.
what? Yeah.
That's the guarantee, right?
Dang. We're so good.
Wait, but then,
I'm.
oh, and so,
This-
say the specification was change y to x's value, set y to.
Then you would have
It'd be
true.
the exact same thing, but.
No. It would be y gets whatever,
Yeah, it'd be y.
because you're saying you want to change
But
the
it's
value of
still
y,
saying-
but it would still be the same here. Yeah.
Wild.
Okay. Oh, actually, I don't believe it.
That's the next.
That's the next. Specify.
Write it down.
set y to x's value. That's what I was actually going to do. So now, so tell me again what it was.
That'll be up to your expectation.
True.
So it was true, bracket,
Bracket.
true,
Y gets question mark.
y gets question mark,
Bracket X equals Y.
x equals y.
Bracket.
Or y equals x, either way.
Why is it question mark?
Because what this is telling you is that the purpose, what this is telling you is that the purpose of the statement is to change the value of y. See, y is a variable. And so what this is telling you is that what the program needs to do is change the value of y. So this is how you say the purpose is to change the value of y.
We don't actually have to do it then.
In fact, you cannot do it, because if you do it, you would not be writing a specification, you would be writing an implementation.
Okay.
Are you with me on that?
Oh, yeah.
Specification is what it does, implementation is how it does it. So if you actually filled in the statement here, you'd be showing how it does it.
Is the implementation just the middle bit, or is it?
Yes.
Right.
The implementation is the middle bit. And then whenever you actually go to write the program, that's what you
So
do.
whole triple has got like specification and the implementation thrown together.
Yeah, in a complete program, yes.
That's
Like,
the whole triple.
yeah, the whole triple, right,
Got it.
right. Is everybody good? Okay, how about this one? Specify, quote, change x and y to have the same value. Change x and y to have the same value. Now, do that. I want to see if you can do that. Now we're writing a specification, right? So, shape of a specification.
Oh, okay. So bracket
Okay, so
true.
true.
X,
X,
Y.
X, oh yeah.
Yeah,
I was gonna say X gets question mark, Y gets question mark, but that's the same.
right. So this is in general a list.
Yeah,
X, Y gets
question
whatever.
mark, comma, question mark, right?
Oh, comma, question mark. Well, yeah, we normally don't do that. I mean, maybe technically we should, but we normally don't. And then x equals y, right? Okay, is that good? All right, now comes,
Grand finale.
oh, it's not the finale, but it is grand. Specify swap the values of x and y.
Ah.
Specify swap the values of x and y. Now try that. I want to see this. Specify swap the values of x and y.
What if they're the same value?
Well, what if they're not? They could be, in which case if you swapped them, they'd still have the same value. But you have to do it in the general case, because what if they're not? Yeah?
You have to add another variable.
Well, why do you want to add something? You actually have a good point. There's something, we need something else that we don't have yet.
We have to be able to say it's equal.
We need a
to-
temporary variable because you got to put the value of x into something while y takes the x.
But it's not, oh, I see, you're thinking like temp gets x, x gets y, y gets temp.
Right.
No, but that's the implementation. We're not worried about, that's what would go in the state. We don't need that. We don't need that.
In the post condition, we have to say that x and y are swapped, but there's no way to really write that.
Now, I want you guys to listen to exactly what he said.
We did.
Because that was a key idea. What did you say?
In the
It-
post condition, we have to write out formally that x and y were swapped.
Yeah, in the the problem is in the post condition. In the post condition, we have to have a way to say that x and y were swapped, but we don't have a way to say that because what would we have to refer to? We would have to refer to the what values? To the initial values, okay? Now, when you have a situation like this, this is what, have you guys heard about the, have you heard?
Simultaneous.
No, that's part of the, simultaneous has to do with the implementation.
That's all.
Okay, have you heard of the concept of a rigid variable?
Yes.
Oh, good. This is why we need rigid variables. Oh, that's right.
It's
These.
variable, it doesn't change.
Well, no, it's actually not a variable in the program.
So
Right.
do you make
It
that
do-
a
Constant,
precondition?
right?
And you define, yes, what you do,
Do this in the precondition.
So say like A equals X.
it defines the initial, here's what a rigid variable does. I'll write this down in a minute. But what a rigid variable does is it defines the initial value in the precondition so that you can refer to it in the postcondition. Do you see what I mean?
Okay.
That's what it is. Okay, so this specification, let's write all that out. This specification requires a rigid variable. So that's what we're going to use here, okay? A rigid variable. And a rigid variable defines the initial value of a variable in the precondition so it can be used in the postcondition. So a rigid variable defines the initial value in the precondition so it can be used in the postcondition. So it can be used in the postcondition.
Do we need two?
Actually, in this case, we do need two. And why do we need two? Because we want to specify in the postcondition that x has the initial value of y and y has the initial value of x. All right, so now with this in mind, what is the specification going to look like?
A equals X.
Well, actually, here's the convention. What we're going to do is we're going to say x equals, so this is the variable, and the rigid variable is, by convention, is uppercase, and we put serifs on it. Right? So this is right, and because we have to define the initial value for y, and y equals
Take that Y.
rigid y. Okay? Are we good? And now
X, Y equals, gets question mark.
x, y gets question mark, so they are changed. And in the end, what do we
X
say?
equals rigid Y and Y equals X.
Yes, x equals rigid y and y equals rigid x. Now, does everybody see how that, how that works? Okay? So the purpose of this isn't to put any restrictions. The purpose of this precondition is not to put any restrictions on what x and y must be in order for this program to work. The purpose of this precondition is to define what the rigid variables are. Is that good? Okay, and then we'll write them in with serifs. The rigid variables will be written with serifs, like uppercase with serifs. Okay. So the initial value of x is rigid x. The initial value of y is rigid y, and in the end, x has the initial value of y, and y equals the initial value of x. Okay, let's do this. Let's do one more. Specify. Now that we have this rigid variable tool, specify set z to its own absolute value. Set z to its own absolute value. And you can use quote, you can use the you know, the absolute values, you know,
Symbol.
symbol, yeah, you know.
Do we even need a rigid variable?
Yeah.
Now, good question. Maybe we don't need a rigid
Just
variable
say
for this one.
True, z changes, and the postcondition is z equals absolute z.
Right.
Well, are you saying this? Are you saying true
Z gets
Z
question.
doesn't equal
z gets
absolute.
question mark and then
Well, one
z equals absolute z?
But in the end, you can't ever make Z.
But it
You
Oh, right.
have to
Okay.
do.
Yeah.
It's the same thing except for.
Equal absolute rigid z.
Yeah, so in the beginning, z equals rigid z, so we'll put the serifs this way, right? Are we good? And then
Z gets question mark.
z gets question mark,
Bracket.
and then the end,
Z equals.
yeah, z,
absolute value of big Z.
z equals absolute value of that initial value, Good. By Jove, I think we've got it.
Wow.
All right?
That's it.
See you Monday.